Let's get started. So I'm super excited to be here today because LNAI releases are often my favorite ones because they are super end-to-end. And today we are here to talk about what is in Olmo 3 release. And the researchers are joining us today to talk about it. So Kyle and Matt, maybe you can introduce yourselves and Luca, and we can get started.
Sure. Can you hear me? Can you hear me? Also, okay, hey, I'm Kyle. I am one of the researchers on the pre-training team. I'm running on no sleep, so forgive me if I'm a little slow. But I work on data evaluations on the pre-training side with these kind folks. Yeah.
Hi, I am Matt, and like Kyle, I primarily work on pre-training. I mostly only ever work on data type stuff, and for Olmo 3, I also did a bunch of work with the mid-training data pool.
And hello, I'm Luca. Same team as Kyle and Matt, equally underslept. Mostly, I don't know. For Olmo 3 was a little bit of everything, but mostly pre-training, post-training, helping to get this great model out.
Well, that's all of us working in AI, to be frank. All of us are underslept, but we are all going. So I'm super excited for this release because, in my opinion, like recently, like initially, all of the reasoning and agentic AI capabilities relied on the closed source models, and recently with some of the open source models, we have this on, especially in my opinion, on a bigger size. But still they come with non-commercial licenses and stuff. And even if they do, they don't come with the data sets to reproduce things. So it feels like all the time, all of the LNAI releases feels like Christmas for me because you have the models, you have the tooling, especially on GitHub, you have the gems of tools for reproducing the research or building your own stuff based on the models. And you have the data sets as well for every stage of the pre-training and post-training pipeline. So I am super hyped for this release, and thank you for blessing us with all of it. And I would like you to explain first, where does your motivation around this come from?
How you want to do this? Okay. Why don't you start us, Luca? You're dressed to kick us off.
You put on. I don't know. So we started working on Olmo models, I think around ChatGPT release. There were a couple of different working groups there too that, say November 22, saw a couple of exciting launches of language models in the space. Like one big motivator at the time, folks remember, was Galactica, a model that was put out by Fair folks. So we saw this launch of language models. There's clearly like a lot of energy in the space. And even back then, like I remember, we all come from a research background, and there was a conversation in the research community around like, there's really not that much transparency around what goes into these language models, what are they built. Folks had an idea, they were like really research motivated, where they all boil down to like, oh, if I had access to more information about how this model was built, I could do this type of research. And so between ChatGPT launching, between like Llama coming out, a group started building language models that were fully open. One to build language models where instead of just releasing the final model, we'll spend a lot of time and a lot of energy to put out everything that goes into the model itself. That has served us well. The need for that kind of artifacts has stayed constant. If anything, it's increasing because now there is a large number of space of like, it's not just the research that you can do with a fully open model. It affords you like different type of customization that you can take a model, change it, adapt it to your use cases. So the motivation there is really strong. We're lucky that we're part of like a non-for-profit institute where this kind of research is encouraged, and this kind of like building this artifact is get great reception. But that's where it all started. I don't know. Did I miss anything, Kyle or Matt?
No, I think that pretty much covers it. I think we all kind of view ourselves as scientists, and then the notion of science is, being as open with everything that we're doing as possible, so others can follow along, make sure we're not doing anything sketchy, and doing everything fully open source kind of is, morally good. It feels good that we can be in the business of like building bridges over moats and showing the world that these are all the steps you would need to take to make a really great language model. This is not something just like gated behind these like very large tech companies.
And perhaps we could talk about what is being released with this release itself. The model, like break down the models a bit by the pre-training stages and the benchmark results that you got.
Yeah. This release, I guess, like kind of like our previous releases, the artifacts we release data, training code, model weights. In this particular release, we're releasing a family of models at a 7B scale and a 32B scale. These models are standard autoregressive dense language transformer language models, very similar in architecture to what we used before in Normal 2. But the big distinguishing factor here is with we're developing these models to showcase our ability to control the data through all stages of base model development, pre-training, mid-training, and long context extension, release data, artifacts, and model checkpoints specific to each of these stages, which encompasses our base model at both 32 and 7B scale. And then from there, the interesting thing is we branch into a bunch of different post-training models and associated recipes. So from there, we branch off into, say, for our flagship model, our 32B model, we branch into a thinking model. So like a think reasoning model that we call Olmo 3 Think. But on the 7B side, we also showcase some like other ways of branching off. So if you want to build, say, like an instruct model, that's a lot more verbose, more to the point, really good for your general purpose tasks that you don't spend a lot of reason tokens on. We show how you can branch from our base model also to develop an instruct model through a slightly modified recipe, and also a RL0 model, what is like our experimental kind of cool, like what if you just don't do SFT and DPO and you go from base model straight to RL? What happens? We can study that artifact. So we just showcase these different branches, and that's kind of captures the spirit of like how we think about these models. Base model, do things really rigorously, very methodologically. It's 90% of the total compute. So have this very clean linear progression of developing a curriculum and training strategy to develop the best foundational base model. And then from there, you should be able to spin off all sorts of really cool things. So we showcase the thinking model with an instruct model with like a straight up to RL0 model, and then see what other people can build from there.
And I would add that, in addition to these models, which are really great and, are live on the playground right now, we also release all of these assets regarding our training code and all of our data processing code. So, if anyone wanted to do their own experimentation with processing of data, there's lots of like super highly engineered, very fast code to do that. And then one key feature of being able to release the data is that we can also release like indexing along with the data. So if, in the playground, if you have this Olmo trace plugged in, if the model responds in a certain way, the text of what was seen in training to cause the model to respond that way is visible. It's just like a key highlight of having like fully open everything and being able to release the data alongside these models.
Really nice. I wanted you to talk a bit about where the thinking models shine specifically, like maybe tool use, maybe reasoning, and maybe a bit of the benchmark results around that.
I mean, it's really like one of the things that's interesting. I'm not post-training. None of us is post-training people, right? You know,
But you're
we
so
help.
opinionated. You're so opinionated about thinking models.
I'm very.
We can talk about it later. It's okay, but I'm curious.
It's great. This is
but
the perfect person. This is the perfect person.
Thinking about it is interesting. So like through development, we had models that look equally good on benchmarks, and you know, you put them up and you play with the model, and one of them, it's a fun model, solves problem, and the other one is absolutely disgusting, and they will benchmark the same. It just like gets like very like sloppy writing, and you can tell that like it stuck itself in a distribution. But you know, they are like, you can tell they're like really good at solving tasks. I think like especially like we didn't get quite there with this release, but you know, there's other work from AI2, like the Daughter tool that came out recently that tried to plug together like thinking models with like tool use, and they work really, really well. Like it's fun to see like I don't know, building models that are basically of the same size and capacity that come from the same base model, but one of it you just scale it up to allow to use test time compute, and the other one is just a simple like instruct model. They behave really different, and the class of problem that they can solve is really different. And it's kind of surprising that it's like, wait, they both started from the same base model, and they share lineage for a lot of model development. So it's kind of interesting. But yeah, it's like it takes a little work to get them to be reliable enough to use, besides, you know, looking good at a benchmark. And then once you can plug in like tools and have them like interact with the environment, then they get like really, really useful.
I think I vaguely saw that it was on par with the latest QN3. Was it the RL0 one or the Instruct?
It's the Thinking Model 1, and it's on par with the first Quen 3 8B. When they refresh with the vision models, especially small sizes, the vision models are actually fairly strong text-only models. It sort of flips around at larger sizes, where like at larger sizes, then, you know, they have thinking variants that are like much better than the vision models. So it sits in between the two. It's like closer to the original Quen 3 8B, not quite as good as the Quen A3 DL, and same for the 32B.
Really cool. I think it's time for us to be joined by the actual researchers for the post-training. As much as I'm sad to say goodbye to you three, to talk about the post-training, RL from verifiable rewards, and open tooling. Yes.
Hello.
I will hand out to you to talk about the training process, if this sounds good.
Sounds good, yeah. Well, there was a question already in the chat about what our training framework looks like. So right now it's split across two code bases, and eventually these are going to merge. But we have Olmo core, that's our pre-training code base. Well, not just pre-training, it was everything that went into our base models, which was actually 3 stages of training: pre-training, mid-training, and long context. That was all done in Olmo core, and that's just a custom PyTorch-based training framework. If you're familiar with Torch Titan, you might see a lot of things that were, I guess, inspired from Torch Titan, and it's basically just all like fundamental PyTorch stuff. Like we're using Torch compile, and things like that that are showcased in Torch Titan. So there's nothing too crazy there except some custom kernels. Like, well, once you get into long context, right, you need to use context parallelism and some other memory saving techniques. So we're using things like like the efficient LM head, fused LM head from Liger kernel, and we've various implementations of flash attention, things like that. And then there's the open instruct code base. Maybe Finbar could talk about that.
Yeah, totally. So on the post-training side of things, there's kind of two main separate avenues of work. There's the like specialized, like supervised learning stuff that we've been doing, right? Like the SFT and the DPO. And we've been trying to move that over to Olmo Core. Right now we're still using OpenInstruct, our post-training code base for DPO, but we plan to move that over to Olmo Core. So they can maintain it. We can say, okay, great, go make it fast, maintain this code for us. But currently, yeah, we're using our Accelerate and Deep Speed based trainer for that. And then on the RL side of things, same story, Accelerate, Deep Speed in our own code base. Again, we're planning to move all of the post-training stuff to use Olmo Core, though, just so that we can, just draft off of the excellent work that Pete and folks have been doing, making training more efficient, and so that we can focus on inference, which is really, when it comes to the reinforcement learning side of things, inference is extremely painful. And I internally I say that my title is VLM mechanic because I just spend all my time tuning it. So hopefully we can move more stuff to Olmo Core and just focus on that.
I wanted to talk about primarily the stages of the like the entire training, the pre-training, mid-training, and post-training, primarily for the instruct and thinking models. Can you talk about them a bit?
Yeah, maybe I can take that. So both the thinking and the instruct models use SFT, DPO, and reinforcement learning training. The pipeline is actually very similar in both cases, with some differences. The data used in both these stages is very different in the two lines, of course, but the training procedures are largely the same. The think model uses SFT on some reasoning traces, which which kind of amplifies the thinking that the model has seen during mid-training as well, and followed by DPO, followed by reinforcement learning, which has a mixture of both verifiable and language model as a judge kind of rewards. And in the case of the instruct model, we found that it was actually quite helpful, mostly for reasoning tasks, when we start off the SFT model for the think side. So instead of starting from the mid-train checkpoint, we took the model after it has gone through SFT for thinking, and we continued doing SFT training for the instruct model on that checkpoint. And other than the fact that we used reasoning traces in SFT for the think model, that we did not have in the case of instruct. Of course, we did not have any of those reasoning traces in SFT. And they also followed a very similar path of SFT followed by DPO followed by RLVR. Of course, RL with verifiable and non-verifiable rewards. And one big difference in the SFT side of the instruct model is that we trained the instruct models also for function calling or tool use. So that is something that was a skill of focus for the instruct models. Yeah.
And I can speak to the base model training that preceded the post-training that led to these different paths, these post-train models. There were 3 stages, as Pete was saying, of base model training, the 5.9T token pre-training stage, which consisted of mostly web data, but we introduced extensive processes of deduplication, quality filtering, quality upsampling and mixing, and topic partitioning to ensure that the quality of this data was very high. And then when we reached the 100B token mid-training phase, what we were doing is focusing in on a set of capabilities, upping the quality of the data and focusing in on improving performance in things like math, code, general knowledge question answering, both reading comprehension, multiple choice, and then also adding data to lay the foundation for these post-trained models with some instruction data and some reasoning trace data, thinking trace data to improve the post-trainability of the model. And then there was one final stage, which was the long context extension phase, which consisted of longer PDF data, scientific PDF data, as well as some synthetic augmentation to train the model in information extraction from these longer documents. And so there was extensive data curation processes for all three of these stages that made use of sort of distributed source investigation among all researchers and then centralized integration tests proceeding in a loop to ensure that we were getting data of the highest quality.
So for the datasets, so you also released Olmo 3 for the pre-training and Dolmino for mid-training. For the long context extension part that you just mentioned, there is Longmino. And there is, I also saw on the Hugging Face collection, there is Dolce for DPO, SFT, and I think separately for RLVR, but I'm not super sure. So like which I wanted to ask specifically which languages they support, how were they curated, or am I asking the wrong people and should I bring back Kyle and others?
Yeah, for pre-training, in terms of languages, the focus is on English. The data curation process, as I mentioned, involved a lot of quality filtering, partitioning, and just very different focuses in terms of the types of capabilities and the specificity of the capabilities that were of focus in a given training phase. So during pre-training, we have much more general web data and an amount of code data, scientific data, et cetera. And then in mid-training, we have much more specific data focused on really boosting, affording targeted boosts to specific capabilities that were priorities for us and making the model more post-trainable, both for the instruct pathway and for the think pathway. And then long context, of course, the purpose of this, which was a new introduction for Olmo 3, was to enable the models to have long context capabilities over longer documents. So those were the Dolma 3 mix, the Dolmino mix for mid-training, and the Longmino mix for long context.
Yeah, and for Dolce as well, the focus is on English. We talked about the skills that we were interested in for Olmo 3, and yeah, so we had data focusing on math, on reasoning, on function calling or tool use, as I had mentioned earlier, and data for improving the chat capabilities of the model. We had data sets focusing on these skills, particularly in the SFT and the RL mixes, because we wanted to improve these. We found that we could improve these capabilities a lot in these two phases. And in the DPO phase, we more than the focus on skills itself, we pushed more on the usability of the model by curating appropriate contrastive pairs. So we did not have a specific skill focus in DPO, but we did mostly ensure that the model is easier to chat with and doesn't output responses that are too long, especially for the instruct model and so on. Yeah, that's the Dolce, SFT, DPO, and RL mixes.
I wanted to ask specifically about the RLVR. Did you observe a lot of improvements on top of the DPO when you applied RLVR and why it actually, like, how much did it add up by means of the factuality, the math, and the code generation that you observed beyond SFT and DPO specifically?
Finbar, did you want to take that?
Yeah, I was going to say, Pradeep, you might be better suited to answer that.
Yeah, we found greater improvements on by using RLVR at the 32B scale than the 7B scale. But we did see decent improvements, particularly on math and reasoning tasks at both 7B and 32B. I have to pull up the results to actually comment on the specific improvements, but yeah, I hope that answers your question.
Thanks. I wanted to ask if you have any nice stories from the training of this model, like if you had any issues in scaling or issues with data mixture, or like how did you figure out your way back to be on track to release the model?
Yeah, so I have some stories. So I think one of them was that we switched our model sharding just before launching our big RL training runs. And what we did was we switched from sharding we had done some of our test runs with a smaller context length and just forgot to run the full context length in our tests. And so we discovered, basically as we were launching that we had to figure out a different sharding strategy. And so we switched from sharding the weights within a single node to sharding them across the entire training setup that we had. And then 2 days later, we discovered that in doing this, we had broken our checkpointing code, which was designed with having everything on a single node. And so we had, some frantic, some frantic time trying to figure out how to fix that to make sure we didn't lose all of our progress. So that was fun. And then another story.
Did you actually lose the progress, or like did you have to, like, how did it?
So we were lucky in that we have two checkpointing setups. One of them saves the model, just the model, and it has a different code path than the actual, like I think it exports it in the Hugging Face format. And then our other code path uses, with the standard torch checkpoint code. And so it saves like the sharded version of it, but it only ran on the main process. And so that one was broken. So we lost the optimizer state. So we lost some progress, but we still had the updated weights, and so that ended up being mostly.
You converted back from the transformers, the one that you saved to export it to transformers format. You converted back to the original PyTorch and then just restarted with another optimizer. Is that how it?
Yeah, that's exactly.
Okay, cool story. I wanted to ask lastly about the open tooling that AI2 releases with the Olmo core, Open Abstract, the RLVR scripts. Can you talk a bit about them?
Sure. I can talk a little bit about OpenStruct, as that's my baby. So what's been particularly exciting on the infrastructure side of things for the Olmo 3 release compared to Olmo 4 is that we were able to make our reinforcement learning runs 4 times faster in that, like the literal wall clock time if you're running an experiment with the code today versus the code, this summer it would take 4 times less to finish. And so if you are, and a lot of these changes, it's all public, it's all in OpenInstruct, our post-training code base. And if you're interested in doing a gRPO training run, you should be able to just take this code and run it. In OpenInstruct, we've really prioritized flexibility. So we integrate fully with Hugging Face. You can take any model off of there. And a lot of the changes are also in the way that we have our actors set up. So if you're someone who's looking to implement your own reinforcement learning pipeline, you should be able to take the actors out, and you could hook them up in your own setup, and that should work quite nicely. But yeah, all of our training scripts were checked in this morning by me, and so we're able to. So if you want to replicate any of the post-training work, that's all available there.
Really cool. Thank you so much. And I wanted to come towards the end of this stream. So for the model artifacts, in total, LNAI releases the model weights in every single stage, both for 7B and 32B, and for compatible with transformers. You can play with them on Hugging Face by pulling directly, or you can also play with them on AI2 Playground. And these artifacts also come with, so basically there is models, there is data sets, and as I mentioned, these data sets are throughout these model training lifecycle. And on top of these, there is also tooling that is on GitHub that you can reach out. So basically, this divides into two. Firstly, there is the Hugging Face collection. Let me tell you the link. It is, give me a sec, hf.co/collection/LNAI/Olmo-3. Over there, you can get all of the models and the data sets. And there is, on GitHub, there is all of the tools and everything that we have previously mentioned. And also on the model cards and the and lnai.org/Olmo, you get the evaluations. And there's also how-to resources on docs.lnai.org, which is the documentation of LNAI. There is everything over there. So to wrap up, there is the Hugging Face collection, where there is the models and the data sets. There is GitHub repositories, where there is the tooling for these, for pre-training, post-training, everything. If you want to reproduce with other models or with other data sets, like you take the Olmo 3 model and apply it with another data set, or you take another model and apply the techniques with a custom data set, and even more stuff. There is tools for data duplication, etc. And you can learn more at docs.lnai.org. And I am actually very excited because I think there will be more upcoming work being released, right? I would be super happy as a person working in multimodal if you actually had multimodal model, but no biggie if you don't. But I would love it if you could talk a bit about the upcoming work that you will release soon.
So there are, I guess, given all that we have done so far for Olmo 3, there are also a bunch of things that we couldn't do in the time. So there are some obvious next steps, obvious to-do items that we have next. Some of these are we've released Instruct and Think models at 7B, but we've only released the Think model at 32B. We also plan to release an Instruct 32B pretty soon. And also there are some differences between the Think and Instruct models. We do plan to build models that do not have such differences, particularly the tool use and the function calling feature. We've implemented that only on the Instruct side, but we plan to also build a model with both thinking and tool use within the same model. That is also upcoming. Those are some obvious next steps. That's what you can expect within the next few weeks to a month.
Thank you so much. We can wrap up if you have some things you can expect from the community. You can give a shout out, perhaps.
Well, I think, I would love to just hear more from the community, more just feedback, see what they think of the model, and if there's any, areas for improvement. We're always looking to improve. So, either, on the models, or if they want to check out OpenInstruct, I'd love to, hear more about what we could do to make it more useful for the community. And if there's any, issues with the model that could make them more usable, that's something I'd love to hear about.
Yeah, and generally the purpose of releasing the entire model flow, as we're doing with Olmo 3, is to enable just a ton of insightful research with respect to how these models work, how data operates, how training operates with these models, what's effective, what's less effective, and interventions can happen at any stage of the entire flow, given what we're releasing. So absolutely call to the community to jump on that and help everyone make progress together.
Well, I would particularly be super excited for people building stuff on top of Olmo 3, maybe some fine tunes, some agentic use cases and apps, and release them in the open. So in case you would like to build stuff, or like you come across some interesting finding, maybe we can meet at the model discussion tabs on Hugging Face or GitHub repository of the tooling. If you have something you figured out with the tooling, feel free to open issues or discussions over there. And I would like to thank LNAI team and the audience for listening. And we are looking forward to see what you are going to build on the fully open research stack, the models, the data, tooling, and everything in the open. And I have heard there is going to be a Discord after party of the release, and you can go there by going to discard.gg/AI2. And thanks a lot again for the release and blessing us as usual with the models.
Thanks for hosting us.
Yeah, thanks.
Thanks. It was great chatting.